Let's wait till. All right. Now I'm recording the class. All right. Again, as I told you, we've covered this before, but we will go through it quickly. So you will to just to review it. So I'm searching for the pointer. All right, this is the pen. Okay. So Boolean algebra. We've covered most of the parts of the Boolean algebra, but before starting with Boolean algebra, I want to remind you about the main or the basic things that we talked about. That in our system or in our discussion, we are going to use the binary system. Why binary? Because binary means I have only 0 and 1, and 0 is off and 1 is on. And this is the main states of any electronic devices. So 1 second. Yes, Kevin. All right. So these are the main states for any electronic devices, because we are going to use this representation to represent other number system. Like you cannot use any electronic devices, any electronic device to perform some operations on decimal number system or on octal number system, etc. So we can process only binary number system. That's why, if you remember, we said there's a big difference, or sorry, we need to link what the human understands, which are the decimal numbers 0, 1, 2, up to 9, and the machine, what the machine understands, which is 0, 1. That's why we studied the conversion between them. All right. So if I want to, for example, to perform this operation, 1 or let's say 3 plus 2. As a human, I understand this, but the machine doesn't understand. I have to convert 3 into binary, which is 0, 1, 1, and I convert 2 to binary, which is 0, 1, 0. Perform the operation, okay? Then I'll get the result, which is, for example, if you remember, we said 0, 1, 0 plus 0, 1, 1. That means 1, 0, 1. Okay? Then the answer is 1, 0, 1. The human, again, cannot understand this. Then I have to convert it back to decimal, which is 5. So this is the entire story of having two number system. One number system that the human can understand, and another system that the machine can understand. Whenever you want to perform any operation, you have to convert them into binary, perform the operation, and convert them back to decimal so the human can understand. Is this idea clear? All right. So that's why we focus on mainly about on two number systems, which are the binary and decimal. We talked about the OR gate, and we say the OR gate is very much similar to plus operation or addition, but it's not addition. OR gate is not addition. Although I'm using the same symbol, but it's not addition at all. It's very much similar to it, but it's not it. Now, in OR gate, we discussed that if you have two inputs, X and Y, and we've got an example, practical example about this. 0 plus 0 will give me 0. 0 plus 1 will give me 1. 1 plus 0 will give me 1. But 1 plus 1, these are addition, if you can. But this one is different. 1 plus 1, or in other words, 1 or 1 is equal to 1. Okay, because it's an OR gate, not an addition. Okay, in general, I can say the OR gate, any true case or any true value will have the result to be, or will force the result to be true always. Only one case which is false, the output will be false. It's when both inputs are zeros. The AND gate is the opposite, and again we are using this or dot sometimes. It's very much similar to multiplication. Okay, very much similar because 0 and 0 equals 0, 0 and 1 equals 0, 1 and 0 equal 0, 1 and 1 is equal to 1. So I have only one case that the output will be 1 when both or all the inputs are 1. The NOT gate is very easy. It will invert, or it inverts the signal or inverts the input. If I give 0, then the output will be 1. If I give it 1, the output will be 0. We talked again also about Boolean algebra, and we say it's a 5-tuple. 5-tuple means 5 elements in the set that have B, the set, plus, which is, if you remember, and you have to remember, it's an additive operation. Additive is not addition. Okay, additive operation, and dot or asterisk, which is the multiplicative operation, the complement, the 0 and the 1. We said for any algebra, and if you go back and check our previous discussion, you will find that I compare this with decimal numbers also. Okay. Now in Boolean algebra, we took the axioms, which are the closure. The closure means when I perform the operation, any operation in algebra on any two elements, then the output or the result will be an element or belongs to the same set. That means A belongs to B. A belongs to capital B. I can try it like this. This belongs to capital B. B also belongs to capital B. Then the result should also be a member of B. Okay, this is called closure. A closure. All right, closure. Now cardinality. If A is a Boolean, then A prime is a Boolean. Again, we can prove it. If A is a Boolean, if A is equal to 1, then A prime equals to 0, right? That means this one belongs to B, and this one belongs to B. If A equals 0, then A prime equals to 1. This belongs to B, and this belongs to B. So any element, this is called cardinality. Any element in B, if it's a member of, if it belongs to B, when I say B is B capital, the Boolean set, then its complement is also a member of this set. Now A plus B, commutative. I remember you used to call in schools, maybe you remember, or in general mathematics, you call it ibdaliya. That means A plus B is equal to B plus A. The location of the operand is not important. Whether to find A plus B or plus B, both will be the same value. Again, A dot or and B is equal to B and A, the same thing, commutative. Associative. As you remember, when we discussed, we said OR and the AND operations are binary operations. And I told you binary doesn't mean that they are using for binary numbers only. That means they take two operands. only. So I cannot apply A plus B plus C directly. I have to divide them into two parts. First, I find A plus B, then the result, which is, for example, R, will be added to, will be ORed with C. Or I can take B and C and then ORed again. Again, and the same story is applicable. And please don't tell me that you are talking very fast, because we've explained everything in the previous lecture, but it's my habit to just to review, to conduct a very fast review to what we've got in the previous lecture. So you will be ready for the next discussion. Again, distribution. And again, I remind you here, very much similar to decimal. A and B plus C, I can distribute A on the elements inside the parentheses, then A and B plus A and C, A and B plus A and C. But this is something new. This one is a bit strange in mathematics, because we are talking about binary. This is only applicable, only correct in binary. This one. It's not applicable at all in any other number system but binary. You cannot distribute the addition or the additive operation over the multiplicative operation. In this case, no, I cannot. I can, in binary, I can distribute this A or the additive operation on the multiplicative operation. That's why the result is A plus B times A plus C. Okay. Identity element. It's strange, of course. You learned in schools that the identity element always is 1. I remember you call it in schools the answer al-muhayyid or something like this. But here, 0 is identity element for plus. Okay. That means when I OR any value for A, I will take either 0 or 1. With 0, the result will be the same. I can prove it like this. A will take 0 or 1. Okay, here A plus or 0. So 0 or 0 equal to 0. 1 or 0 equals to 1. So I can find the output is equal to the input here. 0, 1, 0, 1. Same thing, identity for AND. Again, try to prove it like this. A dot 1 or AND 1. He will take either 0 or 1. 0 or 1 is equal to 0. 1 or 1 is equal to 1. I think it's clear. So this is the the proof that we have identity for multiplicative operation and for additive operation. Complement. Now, for complement, we say A prime. Now, how many variables do we have here? Remember, in the truth table, usually I say 2 to the number of inputs, right? Is that correct? How many numbers we have now? Please answer. How many inputs do we have? How many will be in the truth table? Yes, who's speaking? If you cannot speak, okay, 2. Nargis telling that we have 2. All right. Others, please answer. If you cannot write, then speak. If you cannot speak, then write. 2. Walid. What? Sorry. What telling 2? All right. Anybody else? 2. That means we agree that I have, for example, 0, 0, 0, 1, 1, 0, and 1, 1. Am I correct? Okay.
Yes.
I'm not correct at all. Why? Because I'm here talking about A and A prime. See, I write it here. I have another space. A and A prime. I cannot say A and A prime both are equal to 0, correct? If A is equal to 0, then for sure A prime has to equal to 1. If A is equal to 1, then for sure A prime should be 0. واضح؟ ليش ما عندي 4؟ لأنه أنا بتعامل مع نفس المتغير اللي هو A والA prime. إذا كانت الA 0 for sure أكيد ولا يقبل الخطأ إنه الA prime لازم تكون 1. مستحيل تكون عندي الA والA prime اثنينهم zeros. لأنه الA prime هي الcomplement. Okay. If A is equal to 1, then for sure A is equal to 0. Then if I apply this, A or A, 0 or 1, this is the OR. 1 or 0 equal 1. Then it's always 1, correct? The other option is, if I'm using AND, then 0 and 1 equal to 0. 1 and 0 is equal to 0. Then A plus A prime always equal to 1. A dot A prime always equal to 0. واضح؟ Okay. Now about the operations, you can write AB. That means A dot B, which means A asterisk B, which means A and or and capital B. Okay, it's all right. This is just a notification. Now, operator order of precedence is now. Remember this always. There's an ambiguity about how to implement or how to execute the numbers. Now, if I ask you for, in regular mathematics, if I ask you to find 2 times 5 plus 3, how much is it? Anybody can give me the answer? Sorry.
أول شيء راح نضرب وبعد
Okay.
ما نضرب راح نجمع.
What's the
يكون ناقص
answer?
13. 13.
13. You say you are telling 13. Someone else has answered also. 13. All right. So the answer is 13. Why? Why not 16? 5 plus 3 equal 8, then multiplied by 2 equals 16.
Because the first thing, if you have a bracket, we'll start from bracket.
All right.
After that, you have multiplications. We'll do the mathematics operation. After that, minus or plus, the last one.
Perfect. So you're talking about the order of execution, order of implementation. Very good. See, actually, the order is between. We will implement it between. Implement the operation between parentheses, then the complement, then the and, then the or. In this case, if I put parentheses here, then the answer will be 16. So if I have the same thing is applicable on Boolean algebra, A or B dot C, then equal A or B dot C between parentheses, which is not equal at all to A plus B multiplied by, or not multiplied, ANDed by C. Also, A, B prime, first I find the B prime, then I execute the other operation. So this is very important to implement or to maintain the sequence of implementation. Now, these are theory. By the way, I don't want you to memorize this theory. If I give you a question in the exam, you can open it or put it next to you. I don't care. I don't mind. So the first theory is idempotent. No, idempotent. I want to prove this. A plus or A is equal to A always, and A or A is equal to A always. I'll add or a blank slides so I can use them in my proof. Okay. Where am I? Yeah, all right. Okay. All right. So I want to prove prove this. First, I just want to have the pen. All right. Okay. So I want to prove that A or A is always equal to A. This is called proof by truth table. I'll take all the possible cases, as we said, as we did before, A, A, A. A or A is always equals to A. So I'll have 0, 0, and 1, 1 only. Why only? Because it's the same variable, right? 0 or 0 is equal to 0. 1 or 1 is equal to 1. So if you see that 0, 1 is, or A is equal to A or A. That means, how about the other option, which is A and A, 0, 0, this is A not 9, and 1, 1. A dot A, 0 and 0 is equal to 0. 1 and 1 is equal to 1. And the result is the same as A. All right? So this is what I call the idempotent theorem. The other thing, boundedness. This we have proved it, right? Let's see. No, we didn't prove it. We proved the other one. That means any A, if it's ORed with 1, then the output will be 1. Multiplied or AND with 0, the output will be 0. Absorption. If I have A plus A dot B always equal to A. How to prove this using again A and A plus B. Now I want to prove this. I'll prove only this proof. Okay? How to prove it? Using truth table. I'll show you. Please focus with me. Okay? Then I have two inputs, which are A and B. The cases that they will take 0, 0, 0, 1, 1, 0, and 1, 1. Okay? Then, what I want to prove here? I want to prove that A plus A dot B equal A. A plus A dot B equals A. Then I'll find first, as I said, first I'll try to find AB. Then after I finish, I'll find A plus A dot B. Okay? AB, 0, 0 will give me 0. 0, 1 will give me 0. 1, 0, 0. 1, 1, 1. A plus AB. Now, I'll take this A and OR it with this column. Okay, so that means 0 or 0 equal to 0. 0 or 0 equal to 1 or 0 equals to 1, and 1 or 1 equals to 1. Now, if you compare the result, this result, if you compare it with this, 0, 0, 0, 0, 1, 1, and 1, 1. That means A plus A dot B equals to A, correct? It's not equal to B, it's equal to A because it's identical. Whenever A is 0, then the result, the output is 0. Whenever, now I'll give you some time to prove that A multiplied by B, A plus B is equal to A. Okay, A dot A plus B equals A. I want your proof now. I'll give you. Please just pick up your a piece of paper and try to solve it. Then I'll give you 2 minutes or 3 minutes. I'll be back with you to check what you've done.
Yes, Mister. It's equal.
All right, ملوك. Let me see. ملوك راح تعبين رقبتي قلب الورقة. All right, 0 0 1 1 1 0 1 0 1 A plus B is equal to 0, 1, 1, 1. Perfect. Perfect. Thank you very much. Excellent. So, as Miluk answered, I have A, B, A plus B, and A dot A plus B. Then I have 0, 0, 0, 1, 1, 0, and 1, 1. Then 0 or 0, 0, 0 or 1, 1, 1, and 1. Now, I want to find the relationship or the ANDing between these two things. 0 or 0 equal to 0. 0 or 1 equal to 0. 1, 1. So if I compare this with A, then it will be equal to A. Perfect. Thank you very much. Okay, let's see. Ibtisam, yes, correct. But you have to consider all the cases. ممتاز ابتسام انه نبهتينا لهذه النقطة. لازم تعتمد او تاخذوا كل الاحتمالات اللي هي كل الاحتمالات ممكن ياخذها بالتروث تيبل. فلهذا السبب صحيحة هذه بس لازم تعمليها الى كل الحالات. وعد 0 0 equals 0 1 1. Perfect وعد. Thank you very much. نرجس 0 0 0 1 1 0. Okay, 0. Perfect, Nargis. Thank you very much. And Ibtisam, all right. So the idea is clear. Perfect. Thank you very much. Well done. All right, let's continue. Simplification theorem. Now talking about simplification theorem, actually there are two ways of simplification. The first one is using the theorems that we've studied. For example, in this case, you can simplify this by applying x. We will take x as common divisor أو عامل مشترك مثل ما احنا كنا نسميه. x راح يبقى عندي y plus y prime. y plus y prime أطبق عليه القانون دائما always is equal to 1. Then this equal x dot 1 which equals to x. All right. Again, x plus x y. Here also I can take x as common divisor لأنه هذا ينطبق عليه. x راح يساوي x plus y which is equal to x. In general هذه القوانين لطيفة جدا إنه تعرفوها وتطلعوا عليها، بس هذه بصراحة ما راح تنفعنا بالتبسيط على الرغم من إنه هي مستخدمة في كثير من الكورسات. تعطي التبسيط هذا يعتبروه هو التبسيط المعتمد في تبسيط الدوائر الإلكترونية. أنا ما راح أعتمد عليه، أنا راح أعتمد على نظريات أخرى. فهذا فقط لمعرفتكم، فقط حتى تعرفون إنه هذا ممكن إنه استخدمه في السمبليفيكيشن. Principles of duality. طبعا الزيرو والوانز هم الديوال معناته ثنائي او في علاقه بيناتهم. So if you want to by interchanging اذا تريد تحول اي معادله باستخدام principles of duality by interchanging the and into or and vice versa، يعني اي and تلاقيه في المعادله تحوله الى or، اي or تحوله الى and. 0 and 1 اي 0 يصادفك تحوله الى 1 واي 1 تحوله إلى 0. فبالنتيجة راح يطلع عندي نفس النتيجة. So A and 1 and 0 plus or A prime equals 0. شوف أرجع أحول هذه. ال A راح يصير A يبقى. ال and يصير or. ال 1 يصير 0. أوكي. ال and يصير or. ال 0 يصير 1. اوكي. الاور يصير and. اوكي. هو A برايم اوكي النتيجه هنا كانت 0 فالنتيجه راح تطلع عندي 1. هذه يسموها principles of duality. راح تفكرون تقولوا طيب ليش انا اوجع راسي بهذا الشيء؟ طبعا هذه بعدين راح ناخذها بانه نستفاد منها في نظريه اسميها نظريه دي مورغان اللي هي راح استخدمها في تحويل نوع معين من الدوائر الالكترونيه الى نوع اخر. That's it. I don't want anymore. ما احتاج منكم اي شيء اضافي عدا هذه النقاط اللي تكلمنا عليها. Now proof by truth table. هذا ال proof by truth table احنا already we covered it. This one. If I want to prove this, then I will consider how many variables. First point you have to consider how many variables do I have. 1, 2, and 3. Then I suppose to have 2 to the power 3, which equals to 8. I have a truth table that contains 8 rows. Equal A plus B. I have to find A plus B. I have to find A plus C. Then I do the ANDing, okay, in truth table. So here, if you can see, this is the answer. First 3 variables, each with 2 values. Yes, 0, 1. So this is the case. Remember, I want to keep this in your mind. A plus B dot C. A plus B dot C. I want to prove this is equal to A plus B dot A plus C. إذا تذكرون هذه اللي التوزيع الديستريبيوشن اللي قلت لكم عليه، هذا يطبق فقط في الباينري، ما ممكن إني أطبقه في أي شيء آخر غير الباينري. So I'll start first. I'll create the truth table. I'll put all the inputs. Okay. A, B, C, 0, 0, 0, and again I want you to remember this 1, 2, and 4. That means this changes its value every 1 time. This changed its value 2 times. This is 4 every 4 times. Now I find B dot C. Of course, I'll consider only these things: 0 and 0, 0, 0 and 1, 0, 1 and 0, 0, 1 and 1 equals to 1. By the way, to make things easier for you, in ANDing, يعني حتى أبسط لكم العملية وراح أعيد لكم إياها مرة ثانية. في الأندنج ما في داعي تاخذ كل الاحتمالات. أجي أدور على الحالة اللي فيها 1 1 فقط. أوكي؟ 1 1 عندي هنا ال 1 1 أحط أمامها 1 إذا كانت ANDing، والباقي زيروز أوتوماتيكلي. أوكي؟ ما في داعي أتعب نفسي و أظني أدور 1 1 0 1 إلى آخره، هذا تكسب وقت فيها. في الANDing again, in ANDing search for the case where both inputs are ones. In this case, the output will be 1 and others are 0. Okay, how about in ORing? بالOR. في الOR ابحث عن الحالة اللي فيها 0 0. Here I have A or B صح؟ فبين ال A وال B هذه 0 0 وهذه 0 0. ما عندي بعد حالة 0 0 أخرى. لما يكون عندي 0 0 أحط 0 والباقي اوتوماتيكالي يصير عندي 1. اوكي، ما في داعي اني اقعد اشيك الحالات واظني 0 or 1 or 1 or 0 etc. فقط again I'll search for in ANDing I'll search for 1 1. In ORing I'll search for 0 0. That's it. Now for example, if we are talking about the other one, this one, A or C, I'll delete these things. Okay, A or C. I want to find A or C. What I'll do, I'll search for the cases where A is equal 0 and C is equal 0. I'll go here, A and C. Remember this, A and C. This is the first case. Now 0, 1, 0, 0. This also A and C both are zeros. That's it, right? Then I'll put here 0, and I'll come to this case and put 0, and the others are 1. سهلة صح? Same thing. So I'll find B dot C, then A plus B dot C are the same thing. Now I'll compare A, or I'll find the operation between A and this one. What I have, what kind of operation do I have? It's OR. Then I'll search for 0, 0. This is 0, 0, 0, 0, 0, 0. Okay, no, this is not the right. So I have 0, 0, 0, 0, 0, 0. I'll have 3 zeros, and the rest automatically are ones. So I found A plus BC equals yes, plus BC. This is the these are the values, and now I have to find the other part, which is this one. A plus C. I'll find A plus C. I'll find A plus B. Then find the ending between them. This A plus C, A plus B, A plus C. Find the ending. At the end, في النهاية راح آخذ هذه أقارنها مع هذه. الآن 0 0 0 0 0 0 0 1 1 1 1 1 and the other ones, so they are equal. إذا طلعت عندي حالة واحدة فقط غير متساوية إذا هم not equal، لأنه فرضنا إنه هذه كانت 0، فبهاي الحالة راح أقول إنه الاثنين أو الشيء مو صحيح ولا يمكن إثباته. واضح؟ All right, very well. Proof using theorem. Proof using theorem. I don't want you to bother yourself with this now because it'll be covered somewhere else. So that's it. I think this will be covered in the next slides. في أحد عنده سؤال؟ رجاء راح أفتح لكم الأسئلة الآن لأنه راح أبدي في محاضرة أخرى، بس أتأكد إن أنا حاط لكم إياها. Upload. Okay. اوكي راح ناخذ توتوريال الان، خلينا ما اعطيكم شيء زياده. المحاضره القادمه ان شاء الله نبدي في more gates minimization and mixture and max term sorry. فبالمحاضره القادمه راح ناخذ هذه، بس الان انا راح افتح معكم الدسكشن واعطيكم بعض الاكزامبلز. How to close it. Okay. And also I'll give you some examples from من الكتاب. اوكي. بما انه انتم ما استلمتوا الكتب اعتقد. Documents. Okay. Not this one. Digital. اوكي طبعا هذا كتابكم هو الاصح، بس انا افضل استخدم الفيفث اديشن نفس الشيء. اوكي فخلينا ناخذ بعض الاكزامبلز. بس طبعا هذا احنا قاعدين نتكلم عنه هو chapter 2 اللي هو البوليان الجبرا، بس شوف لكم بالكتاب حتى لما اذا حبيتوا تقرؤون وتطلعون على المزيد. So Boolean algebra, this is what we were discussing, and this is the proof I want اوكي هذا مثل ما شايفين يعني كل البروفز كل الثيوريم موجوده هنا. خلينا ناخذ examples. اوكي راح اعطيكم معادله بدكم تطلعوا لي التروث تيبل لها. alright. Instead of wasting our time, so اوكي راح اكتب لكم معادله بدكم تطلعوا التروث تيبل الى هذه المعادله. فخلينا نبدي هنا. اوكي find the truth table of f equals a plus b c plus c prime. يلا اشتغلوا طلعوا لي التروث تيبل. هذه المعادله امامكم. اوكي بدكم تطلعوا التروث تيبل. Any answers?
Just a minute.
All right, take your time. All right, I'm sorry, I was speaking while it's Sorry guys, I got a phone call. I was discussing the answer of Miluk and the answer of Ibtisam and others while I forgot my microphone mute. So let's again see. I think it's all right, but how many variables do we have? Why 4 here? It's only 3.
We
F
have
is
three.
yeah, F is the result. So if I write F equals to, so we have 3. All right. Here I found some difference between these two answers. Here's 0, 1, and the others are 1. Okay. Ibtisam and Muluk started with 1, 0, and the others are 1. Let's see others. Nargis, 0, 1. Okay, perfect. Wad, why we have a lot of zeros here? I think you C plus C prime. Okay, I'll check it. Very good. Thank you very much. In general, it looks like we are on the right track. ماشيين على الطريق الصحيح والكل ما شاء الله متحمس وقاعد يجاوب بطريقة صحيحة. I will try to answer it very fast. Here I have again 3 variables which are A, B, C, 0, 0, 0. And this, again, I told you to put 4 zeros and 4 ones and separate by this one. Then I have 2 zeros, 2 1, 2 zeros, 2 ones. I have 0, 1, 0, 1, 0, 1, and 0, 1. Then the first part is A plus B. A plus B, this one. I told you with OR what I will search for 1 1. Sorry, for 0 0, correct? So AB here 0 0 1 1 1 1 1 1. Correct? Now this one with C, but in this case we have ANDing. A plus B dot C. So this one with C, then if we have ANDing, then we'll search for the ones. All right, this is 1, and this is 1. The others are not here also 1. نبهوني إذا أخطأ لأنه شوية. Okay, 0 0. تمام. Now this one ORed with C prime, then I have to find C prime. C prime is 1 0 1 0 1 0 and 1 0. Now these two things have all relationship between them. Then F is equal, هنا أبحث عن الوانز صح؟ لا or أبحث عن zeros. Here I have 0. So I have only 1 1 0 1 1 1 1 1 1. So this is the answer of the question, and everybody has done perfect. Thank you very much. And 1 second, please. I need to answer this, to take this call. Sorry guys, I got a phone call. All right, so this is all about today's discussion. I'll meet you next lecture. Please try to read it again. Try to watch the recording again. I'll stop the recording now and download